When a vehicle enters limp mode, it's a signal that the ECU has detected a problem and is actively limiting system functions to protect the vehicle or driver. To effectively diagnose limp mode, we need to use system logic, evidence, and measurement, not guesses or random part swaps. The ECU can't see every detail of sensor or circuit behavior. Instead, it relies on comparing input signals, power, and ground status against expected values. When it detects a difference it can't explain, it sets a DTC and may trigger limp mode. Understanding what the ECU can and cannot see helps you target your diagnosis to the right system or circuit. ECUs use plausibility checks to decide if sensor data makes sense. For example, it might compare throttle position with airflow and engine RPM. If one value disagrees sharply with the others, the ECU may decide a sensor or circuit is faulty, even if the value is still within its normal range. The best way to diagnose limp mode is by following a practical test path. Start by confirming powers and grounds at the affected circuit. Use a meter or test light to check voltage and verify ground with a loaded test where possible. Next, compare your readings against the expected values based on the wiring diagram and known good data. Abnormal results tell you exactly where to look next, while normal results shift your focus to other systems. When you get an abnormal voltage reading or a power ground failure, match your result to the wiring and logic path. For example, a low signal can be caused by a ground fault, a shorted wire, or a failing sensor. Pause to see which path your evidence confirms, so you don't mistake a wiring issue for a failed part. Always cross-check your test results with the ECU's logic and complaint. A frequent mistake is to replace a sensor, throttle body, or even an ECU based only on a code or a single voltage reading. But DTCs point to system behavior, not to a specific failed part. Always confirm with at least one loaded test or corroborated measurement before taking action. Here, the technician compares the seen evidence against the next test instead of repeating the same generic diagnostic reminder. Use this step to name the condition, the observed data, and the confirmation path that separates this scene from the rest of the workflow. This scene narrows the decision to one specific measurement or clue, then points to the next action that confirms or rejects the suspected fault. When diagnosing limp mode, always start with a logic path. Understand what the ECU detects, compare related signals, and confirm problems with loaded tests. Only act when your measurements and logic agree. This approach saves you time and prevents unnecessary part swaps. Remember, successful limp mode diagnosis is all about understanding ECU logic and confirming faults before any repair. Always let the evidence guide your next diagnostic step.